Hello everyone, I am B. Manisha from CSCA section and my roll number is 529. My AAT concept video topic is independent events. Coming to the introduction, first of all, what is probability? Probability means possibility. We use the terms probable and probability to express a likelihood or chance of truth. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced in maths to predict how likely events ought to be happen. The meaning of probability is basically the extent to which something is likely to happen. This is the basic probability theory, which is also used in the probability distribution, where you will learn the possibility of outcomes for a random experiment. To find the probability of a single event to occur, first we should know the total number of possible outcomes. Trial. Any particular performance of a random experiment is called a trial. By experiment or trial in the subject of probability, we mean a random experiment unless otherwise specified. Each trial results in one or more outcomes. Examples: tossing 4 coins, picking 3 balls from a bag containing 10 balls, 4 of which were red and 6 blue, rolling a die. Event. Events in probability can be defined as a set of outcomes of a random experiment. The sample space indicates all possible outcomes of an experiment. Thus, events in probability can also be described as subsets of the sample space. Events in probability are outcomes of random experiments. Any subset of the sample space will form events in probability. The likelihood of occurrence of events in probability can be calculated by dividing the number of favorable outcomes by the total number of outcomes of that experiment. Sample space. There are lots of events like when we toss a coin or toss a die, and we cannot predict the outcomes with certainty, but we can always say all the possible outcomes. These events are what we call a random phenomenon or a random experiment. Probability theory is usually involved with such random phenomena or random experiments, but what is a sample space? A collection of a set of all such possible outcomes is known as a sample space of the experiment. In other words, we can say that in a random experiment, the collection or set of the possible outcomes is referred to as the sample space and is normally denoted by S. The sample space in case of a random experiment is represented within curly brackets. The sample space may depend upon the number of outcomes in an experiment, and the subset of the possible outcomes is referred to as the event. If the number of outcomes is finite, then the sample is known as discrete or finite sample space. Event space. The second element of a probability space is a collection of so-called events F. Events themselves consist of particular groups of outcomes. Thus, the set of events is a collection of subsets of the sample space. Events can be thought of as characteristics of outcomes that can be identified once the experiment has been performed. That is, they are the information scale at which we can view the results of an experiment. In many but not all experiments, we can identify individual outcomes of an experiment. In some experiments, we can identify only certain characteristics of individual outcomes. Thus, the event space characterizes the information that we have available to us about the outcomes of a random experiment. It is the mesh or filter through which we can view the outcomes. Types of events in probability. There are several different types of events in probability. There can be only one sample space for a random experiment. However, there can be many different types of events. Some of the important events in probability are listed below: independent and dependent events, impossible and sure events, simple and compound events, complementary events, mutually exclusive events, exhaustive events, and equally likely events. Coming to the independent events in probability are those events whose outcome does not depend on some previous outcome, No matter how many times an experiment has been conducted, the probability of occurrence of independent events will be the same. For example, tossing a coin is an independent event in probability. Independent events are those events whose occurrence is not dependent on any other event. For example, if we flip a coin in the air and get the outcome as head, then again if we flip the coin, but this time we get the outcome as tail. In both cases, the occurrence of both events is independent of each other. It is one of the types of events in probability. Let us learn here the complete definition of independent events along with its Venn diagram, examples, and how it is different from mutually exclusive events. What are independent events? The exact meaning of independent events defines as the happening of one event does not affect the happening of the other. The probability of occurrence of the two events is independent. This article explains probability of independent events along with examples. An event E can be called an independent of another event F if the probability of occurrence of one event is not affected by the occurrence of the other. Suppose two cards are drawn one after the other. The outcome of the draws is the independent if the first card is put back into the pack of cards before the second draw. If the cards are not replaced back, then the events are not independent. Consider one more example. Suppose a bag contains 5 white and 3 red marbles. Two marbles are drawn from the bag one after another. Consider the events A is equals to drawing a white marble in the first draw. B is equals to drawing a red marble in the second draw. If the marble drawn in the first draw is replaced back in the bag, then A and B are independent events because probability of B remains the same whether we get a white marble or a red marble in the first draw. If A and B are two independent events associated with a random experiment, then probability of A by B is equal to probability of A and probability of B by A is equal to probability of B and vice versa. If S is the sample space of the random experiment, A and B are any two events defined in this sample space. The two events A and B are said to be independent. That is, if probability of A by B is equals to probability of A by B naught is equals to probability of A, or probability of B by A is equals to probability of B by A naught is equals to probability of B, and probability of AB is equals to probability of A into probability of B. Mutually exclusive events. Events that cannot occur at the same time are known as mutually exclusive events. Thus, mutually exclusive events in probability do not have any common outcomes. For example, S is equals to 10, 9, 8, 7, 6, 4, and A is equals to 4, 6, 7, and B is equals to 10, 9, 8. As there is nothing common between sets A and B, thus they are mutually exclusive events. Two events A and B are said to be mutually exclusive events if they cannot occur at the same time. Mutually exclusive events never have an outcome in common. Independent events versus mutually exclusive events. Independent. They cannot be specified based on the outcome of a maiden trial. Mutually exclusive events. They are independent of trials. Independent events can have common outcomes. Mutually exclusive events can never have common outcomes. If A and B are two independent events, then P of A intersection B is equals to probability of B into probability of A. If A and B are two mutually exclusive events, then probability of A intersection B is equals to 0. Independent events Venn diagram. Here we can see the diagram of independent events. If A and B are independent events, then the events A and B naught are also independent. Proof. The events A and B are independent. So probability of A intersection B is equals to probability of A into probability of B. From the Venn diagram, we see that the events A intersection B and A intersection B naught are mutually exclusive and together they form the event A. A is equals to A intersection B union A intersection B naught. Also, probability of A is equals to probability of A intersection B union A intersection B naught, or probability of A is equals to probability of A intersection B plus probability of A intersection B naught, or probability of A is equals to probability of A into probability of B plus probability of A intersection B, or probability of A inter B naught is equals to probability of A into probability of A minus probability of A into probability of B, that is equals probability of A into 1 minus probability of B is equals to probability of A into probability of B naught. Examples: let x and y are two independent events such that probability of x is equals to 0.3 and probability of y is equals to 0.7. Find probability of x and y, p of x or y, probability of y not x, and probability of neither x nor y. And here is the solution. Given p of x is 0.3, p of y is 0.7, events x and y are independent of each other. Probability of x and y is equals to probability of x intersection y, that is equal probability of x into probability of y. Here we have to multiply 0.3 and 0.7. We get 0.21. Probability of x or y. Probability of x union y, that is equals probability of x plus probability of y minus probability of x intersection y. Here we get 0.79. Probability of y not x. Probability of y intersection x naught is equals to probability of y minus probability of x intersection y, that is equal 0.7 minus 0.21, 0.49. And p neither x nor y is equals to probability of x naught intersection y naught, that is equals 1 minus probability of x union y. We can get the answer as 0.21. Let us discuss some important topics again. Independence events in probability are those events whose outcomes does not depend on some previous outcome, no matter how many times an experiment has been conducted. For example, tossing a coin is an independent event in probability. Independent events are those events whose occurrence is not dependent on any other event. For example, if we flip a coin in the air and get the outcome as head, then again if we flip the coin but this time we get the outcome as tail. In both cases, the occurrence of both events is independent of each other. It is one of the types of events in probability. Let us learn here the complete definition of independent events along with its Venn diagram, examples, and how it is different from mutually exclusive events. What are the independent events? The exact meaning of the exact meaning of independent events defines as the happening of one event does not affect the happening of the other. The probability of occurrence of the two events is independent. This article explains probability of independent events along with examples. An event E can be called an independent of another event F if the probability of occurrence of one event is not affected by the occurrence of the other. Suppose two cards are drawn one after the other. The outcome of the draws is independent. The first card is put back into the pack of cards before the second draw. If the cards are not replaced back, then the events are not independent. Consider one more example. Suppose a bag contains 5 white and 3 red marbles. Two marbles are drawn from the bag one after the other. Consider the events A is equals drawing a white marble in the first row, B is equals drawing a red marble in the second row. If the marble drawn in the first row is replaced back in the bag, then A and B are independent events because P of B remains the same whether we get a white marble or a red marble in the first row. If A and B are two independent events associated with a random experiment, then P of A by B is equals to P of A and P of B by A is equal to P of B and vice versa. If S is the sample space of a random experiment and A and B are any two events defined in this sample space, the two events A and B are said to be independent. Mutually exclusive events. Two events A and B are said to be mutually exclusive events if they cannot occur at the same time. Mutually exclusive events never have an outcome in common. Independent events virtual versus mutually exclusive events. They cannot be specified based on the outcome of a maiden trial. They are independent of trials. Can have common outcomes. Can never have common outcomes. If A and B are two independent events, then P of A intersection B is equals to P of B into P of A. If A and B are two mutually exclusive events, then P of A intersection B is equals to 0. Independent events Venn diagram. Here we can see the diagram of independent events. If A and B are independent events, then the events A and B naught are also independent. The events A and B are independent, so P of A intersection B is equals P of A into P of B. Here are the examples. Thank you.